Okay, I'm going to finish this lesson up and then I guess head home. But I wanted to go over some things that I think you should know. And it's just some more functions that go along with that last video that I did. So if you're first starting out Algebra 2 with me, this should be the second video that you can see. And then if you are already in my class, then this is a recap of some things that we have learned in the past, okay? So, right, we talked about functions and then we talked about these standards, right? Being able to graph functions expressed symbolically and show key features of the graph by hand and using technology. And then, oops, wrong thing. Let me switch that over. Yeah, okay. And then graph functions expressed symbolically and show key features of the graph by hand and using technology. So that's A1 if you're in Algebra 1, and then A2 if you were in Algebra 2, but pretty much the same thing. There's just some different definitions of what types of graphs that you're going to be graphing, and we will get to piecewise functions, but not in this. Absolute value functions are definitely going to be in this lesson. Square root we've already covered, cube root we will cover today, and a few other classic functions. So the first one I want to cover is the cubic function, not the cube root function, but the cubic function. So the cubic function if I have y equals x cubed or f of x equals x cubed, we can start to graph this function. So for the cubic function, I specifically like to go from -2 to +2, and you'll see why. Because these numbers will get large very fast. And something to just recap is whenever I plug in a function into any type of polynomial, make sure that if you're going to use your calculator, that you're putting that number in parentheses. Cubic function, you'll find that if you plug in a negative, you get a negative, because whenever you cube a function, you're multiplying it by itself 3 times. But just remember that that negative carries. So if I talk about -2 cubed, right? If I plug in -2 into this function, right? What that's saying is, if I plug in -2, then everywhere that I see an x on the other side of the equation, I'm going to plug in -2. So if I do that, I get f of -2 is equal to -2 cubed, which is equal to -2 times itself 3 times. -2 times -2 is +4 times -2, and then 4 times -2 is -8. So what you'll find is whenever you plug a negative into a cube function, a cubic function, you're going to get a negative back. And you're going to get the cube of that number. Okay, same thing with -1 cubed. So I'll leave these as exercises for you, but -1 times itself is 1. 1 times -1 is -1. So if you plug that into the function, you'll get back -1. If I cube 0, I'll get 0. If I cube 1, that's multiplying 1 by itself 3 times, I'll get 1. And then 2, if I cube that one, I'll get +8. So if I want to graph these functions, I can do that. So what I'm going to do is I'm going to draw my axis here. I'll draw my axis. Right, if I plug in -2, I'm going to get back -8. So -2. Let me erase this guy. Extend him. If I plug in -2, I should get back -8 here. Just going to move this guy. point. Keep the convention there. Sorry about that. So that's 6, 7, and 8. And then 1 and 2. So I want to graph these points, and I'll go with Roy G. Biv again. So if I do red, do this function in red, the first coordinate I'm going to have is -2, -8. So if you take a look here, I'll zoom in on that. -2, -8 is my first coordinate. So if I plug in -2, we just saw that we get back -8. So -2, -8 is a coordinate pair. And then the next coordinate pair is -1, -1. So we're going to plot that. Oop. So I'm going to go ahead and draw it there. It's going to load. I meant to draw it at -1, -1. And then the next one is going to be 0, 0. So if I plug in 0, I get back 0. Then I plug in 1, I get back 1. And then if I plug in 2, I get back 8. And so what I have here is a nice smooth graph. And remember that these polynomial functions, whenever I have something of degree 2 or higher, they're going to have these smooth curves, right? You're not going to have line from there to there. You're going to have this nice bendy shape. So one thing that I would definitely do is whenever I'm trying to find what these shapes look like and kind of get used to their shapes, I would suggest drawing them out. I would suggest practicing, because that's going to get you the information that you need about the graphs. Okay, so that is x cubed. That is the cubic function graphed. So if I switch to the graphic calculator and I go to y equals, we can actually take a look and see what this function looks like. So I'm going to write it, x to the 3rd power, graph it. I get the same graph that I just got, right? I get that nice graphic shape. And so you can kind of see that this function is the same one that I'm seeing over here. And so the graphing calculator is just kind of explaining to us that we are correct there. And so the next function I want to cover is the cube root function. So the cube root function, if I talk about a root, anytime you see a cube, like a 3 inside that groove there, this means cube root. So in other words, anything that I plug into that, you're trying to find 3 numbers that will multiply together to be that number. So sort of like the square root. And the reason why I decided to go with the cubic function first is because we already have the pair. We won't talk about it just yet, but these functions are inverse functions. The last one we did was called the cubic function. This one's called the cube root function, right? Anytime you have a cube, it has a cube root. So since I have the perfect cubes in the outputs over here for this function, I'm actually going to just switch these. So my inputs for these, like I said before, sometimes you're going to choose values that are advantageous. So for cube root, you're always going to choose these 5 numbers to get started. So you're going to start with -8, go to -1, 0, 1, and 8. And so for cube root, I come down here and I write in -1, -8, -1, 0, 1, and 8. And so I'm asking myself, okay, if x is -8, then what is f of -8? Well, I plug that into the cube root. And if I think about it, well, what are 3 numbers that multiply together to be -8? And if you can think of the same number, it's actually going to be -2. Now you might be wondering, okay, but in the last example, whenever we were working the square roots, how come we couldn't plug negatives in, but we can plug negatives in now? Well, if you think about it, 3 negatives multiplied together can become a negative. But with the square root, you're only looking for 2 numbers that multiply together to be that number, and they have to be the same. So the only 2 numbers that fit the bill for a square root are going to be positive, okay? They have to be positive. So if you have a negative inside of a square root, it's called a non-real answer. It's not that mathematicians don't look at those numbers and look and figure things out about them and use them in equations. It's just that they're not going to be numbers that are going to be nice to work out on paper. So they're non-real numbers. In this case, you can multiply negative 2 by itself 3 times and get negative 8. So the output here would be negative 2. And I just want to reiterate this. Just because it's hard to calculate these, you can also use your calculator. So if I go to second quit and I look down here, you can actually find the cube root. So you go to math, and it's number 4. So it's telling you, okay, this is the third root, and then you can also take the xth root if you want to. So whatever value you plug in for x here, that's the root you're taking. So we want to use the cube root. And I want to just show you that negative 8, the cube root of negative 8, the calculator will give us back negative 2. So math works. Math works there. So same thing with negative 1. If I plug in negative 1, I'm going to get back negative 1, right? If I plug it into the function, I'm asking myself what 3 numbers multiplied together will give me negative 1. Well, that's going to equal negative 1. Negative 1 cubed is negative 1. Same thing with 0, right? What number cubed equals 0? Well, that's 0. And then what number cubed equals 1? Well, that's 1. And then what number cubed equals 8 is going to be 2. So I'll leave that to you, but just to show you that it's true and possibly prove it to you if you're confused, is that if I plug in 8 into this cube root function, I'm going to get 2. So then I'll go back. So what this is allowing me to do is graph this function. So I'm going to do that. So I don't need a very defined y-axis, but I do need a pretty large x-axis. Pretty big x-axis. So I'm going to move this guy over here. And this is also, remember, f of x means the same thing, so reiterate that. F of x is just a more fancy way and a more defined way of saying y. And so what I have here is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, and then over here, positive 1, positive 2, positive 3, positive 4, positive 5, positive 6, positive 7, positive 8. And then I'm taking a look at the, extend this axis, graph of this function. And this time I want to go with, I think, another fancier color. So once this loads, I'm going to pick indigo, I think. Yeah. So there we go. We've got indigo. And then we're going to take a look at these points. So the first point, the first value that I'm going to plug in, the first coordinate that I'm going to get for this function is negative 8, negative 2. So negative 8, negative 2. And then the next coordinate that I'm going to get is negative 1, negative 1. And then the next coordinate is 0, 0. And then 1, 1. And then 8, comma 2. So if I draw this in, right, nice smooth curve, I get something that looks kind of like the cubic function, but rotated and flipped. So this is the cube root function, and remember that's part of your standard. Graph functions expressed symbolically and show key features of the graph, specifically square root, cube root, and piecewise defined functions. Include step functions and absolute value functions. We did absolute value functions, we did square root and cube root. We will leave piecewise defined functions and step functions for later. Okay? So back to this. And then, let's see, what else do we need to graph? A few other ones we need to graph. One of them is 2 to the x, and this one takes some thinking about, but this is an exponential function, or an example of an exponential function. But before we get to that, I want to go back and talk about cube root just a little bit more, and we want to make sure that we know why it looks the way that it does, and make sure that our calculator is going to give us the same thing. So if I go over here, I go to y equals, so remember we're typing in this function, and you do the same thing, except this time it's just in the y equals symbol. So you go to math, you go down to cube root, you plug in the x, and then you graph it. And take a look at that. Look, it's this exact same function that we did over here. Amazing. I mean, mine's sloppier because it's written by hand and on a tablet because I've got to replace my pen, but still, it's the same thing, okay? It means the same thing. It's just the calculator is doing it for us, and so what we want to be able to do is, again, by hand, graph these guys. So show key features of the graph by hand and using technology. So we haven't looked at the key features of this graph, that comes later, but we can look at how this function is plotted using the x and y coordinate plane and take a look and get a feel for these functions. So the next thing we want to talk about is the exponential function. So the exponential function is kind of hard. You do want to start with regular negatives, but something that you have to convince yourself with is if this stuff is kind of difficult to understand, especially with the fractions, what you're going to have to do is use your calculator and trust it, okay? So if I have x, f of x, right? F of x is y, which is equal to 2x. The first thing I'm going to start off with is -2, -1, 0, 1, and 2. And I might just do 3 to show you the graph of the function and kind of make it more defined. So let me just extend it here. We're going to graph it up. So if I plug in -2, I get 2 to the -2, right? Anytime I plug a function in, I plug a number into a function, it goes in place of the x's. So right here and right there. So 2 to the -2 is actually equal to a fourth, okay? And that's by properties of exponents. So I just want to make sure that you guys can trust me on that. So if I go over here to the calculator and I type this in and I raise 2 to the -2 power, I'm going to get 0.25. And then if I'm not convinced what that is, if I don't see the decimal, I'm going to convert that to a fraction. That is indeed 1/4. So 0.25 or 1/4, which will make it easy to graph, okay? And then 2 to the -1 is also going to be 1/2. So I'm going to be plugging that in. So I get 2 to the -1, which is 1/2. So if I come back over here to my graphing calculator and I plug that in, 2 to the -1 power is 1/2, 0.5, which is also, just to make sure you see that that's the same fraction that I'm putting there, it is 1/2. So the next thing that's very hard to understand whenever you first see it is 2 to the 0. Anything to the 0 power is going to be 1, okay? So there's reasons for all these. I can kind of go over them here in a second, but it becomes a little confusing whenever you first start it out, and sometimes you just have to take it for truth and then kind of see it unfold in front of your eyes. But here you go, 2 to the 0. Anytime I raise anything to the 0 power, I get 1, okay? So I would definitely note that. Anything to the 0 power equals 1. And that's as long as something that I'm raising to the 0 power is not 0, okay? So in this case, the base cannot be 0. All right, so the next thing I've got to talk about is 2 to the 1st power. And then anything to the 1st power is itself. So 3 to the 1st would be 3. 7 to the 1st would be 7. 1 million to the 1st would be 1 million. So 2 to the 1st is 2. And then hopefully from the square function, you kind of remember the next two. 2 squared is 4, and then hopefully from the cubic function you remember that 2 cubed is 8. So if you take a look, you kind of see a pattern here, and hopefully you see that pattern. Each time I see these outputs, each time I increase x, what I'm doing is taking the previous value and multiplying it by 2. So 1/4 times 2 is a half. 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So I could continue the pattern, right? If I plug in 4, I get 2 to the 4th, which is indeed 16. So that's one way to remember the pattern. Another way to remember the pattern is to look at the graph and even just type it into the calculator. Okay, so let's talk about these negative exponents. So that's another rule that you need to know. Let's say I have a to the negative n power, where n is some integer. Well, this is equal to 1 over a to the n. Okay, so it's just 1 divided by a raised to that power. So whenever I wrote 2 to the negative 2, so let's try and use this formula. Here's an example. Whenever I write 2 to the negative 2, I get back 1 over 2 squared. That's what I get. And so I get 1 over 2 squared, which is 1 over 4. So that's exactly what I got whenever I plug that into the calculator. I got 1/4, and if we take a look up here, I get that back. And then another example would be 2 to the negative 1. It's going to equal 1 over 2 to the first, which is 1/2. And that's it. That's all I have to do for those. So now I just have to plot these points. So I hope that that makes sense. And we're going to go over here and start to plot these points. And if you're kind of unsure of how to plot fractions, well, it's just a partial part of the way. So let's see. I'm going to do light blue for this one. That's what I like to do in calculus. So if I plug in negative 2, I'm going to get back 1/4. So that's going to be left 2 and up 1/4. And then if I plug in negative 1, I'm going to go up 1/2. And then if I plug in 0, I'm going to go up 1. So 0, 1 is my coordinate, so it's always these outputs over here. And then if I plug in 1, I get back 2. And you can plug in more negative points and more positive points and get a better shape for this graph and get more approximations. But what I'm trying to do is get a general shape here and then draw in the shape of the curve. So let's see. I've got 2, 4, so 2, 4, and then 3, 8. And then 4, 16. So it would continue to go upward. And what you'll notice is that it leaves fast. It just diverges fast. Okay, so that function shoots off to infinity. And what you'll notice on this side is that if you continue to plug in smaller negatives, you'll have this part of the function here, this part of the curve here will start to hug the x-axis. Okay. So I'm going to set that scaling to the same on the calculator. Right, I've got negative 4 on this side, and then positive 4 on that side, and then, well, I'll just graph it as is. Let's go to the calculator. Yeah, let's change some of these. So, negative 10, positive 10. Down here, negative 4. Let's clear this guy out. Negative 4. And then clear the next one. Positive 4. No, that should be positive 10. And this should be negative 10. That's my mistake. And then up here, this should be negative 4. And that should be positive 4. So that was my mistake. So I went to window and just changed the window. And all that does is change the scaling of the graph. So now what I want to do is go to y equals and get rid of this guy. And I want to type in 2 to the x power. If I take a look at this graph, kind of see I'm getting that same value, that same type of function. Let's actually change the scaling. Negative 15 to positive 15, so the graph is closer together. It should look somewhat like mine, and if you take a look over here, yeah, it looks really similar. And as you notice, right, if I start to zoom this out, this will blow up to positive infinity, so it will keep going and going and going and kind of shoot up. and then this one will have the x-axis. So we've got one more function to graph. It's probably one of the toughest ones, but that's not going to stop us. It is the reciprocal function. So as your first quiz in my class, some of my students will probably remember this, and then some of them will be hearing it for the first time. So if you are watching this for the first time and you were in my Algebra 2 class in 2021, after summer of 2021, then this is going to be your first quiz in my class, being able to graph these functions and give their names and do them accurately. So I'm going to give you the equation. So f of x equals 1 over x is the equation. So it takes whatever you plug in and reciprocates it. And then we're going to do the x and y table, which is x and f of x table, which is very, very messy. And we're going to start this guy at -3, -2, -1. And then we're going to go into -1 over 2, -1 over 3. And then we're going to skip 0. Something that you need to understand is I cannot plug 0 into this function. So if you are familiar with domain and range, that means that there's a domain issue here. So if I take 1 and divide it by 0 in my calculator, if I try and plug 0 into that function, I'm going to get an error. It says division by 0. So if I go back over here, the first thing I'm going to plug into this function is -3. So if you take a look here, if I plug -3 in here, then that means -3 drops in over here. So that means f of -3 is going to equal -1 over 3. So I'm going to get back the reciprocal of the function, or the inverse of the multiplicative inverse of the function. So -3 becomes -1/3. Same thing with -2. If I plug in -2 over here for x, I'm going to get back -2. So f of -2 equals -1/2. That's what you'll find. And so I get -1 over 2. And then what about -1? Well, if I plug in -1, I'm going to get back 1 over -1. So I get back f of -1 is equal to 1 divided by -1, which is just -1. So I get back -1. So -1 is a nice one to plug in. And then what about fractions? Well, if I plug a fraction into the denominator, what happens is I can multiply by the reciprocal. Okay, so it either reciprocates it, so you can either think about flipping the input, right? So if the input is -1/2, then the reciprocal of these two numbers, if I swap the places of 2 and 1 and keep the negative, I get -2 over 1, which is just -2. So here's a more intensive way of calculating that. If I plug in f of -1/2, if I calculate f of -1/2, then I've got 1 divided by -1 over 2, which is the same thing as 1 being multiplied by the reciprocal, which is 1 times -2 over 1, which is just -2. So that's what's going on over here. I'm plugging in -1/2, and I'm getting back -2. And so since that's going on, I should get back -2 here, and then same thing for -1/3. I should get back -3. And it's the same for the positive numbers. I just have to scale them correctly and put them in the correct order, and then I get the same version of the positive values, the reciprocals over here. So if I plug in +1/3, I'm going to get back +3. And again, you can plug in smaller fractions and larger numbers. I'm just giving you the general shape. So to get the general shape, you're going to want to plug in these x values, okay? Then if I plug in 1/2, 1, 2, and 3, right? If I plug in 1/2, I'm going to get back 2. If I plug in 1, I get back 1. The reciprocal of 1 is itself. Then if I plug in 2, I get back 1/2, and then if I plug in 3, I get back 1/3. So these are my x and y coordinates. They might not look pretty, but what you're going to see is that there is some sort of beauty, that this aesthetic nature, this kind of nice thing that happens whenever we graph 1 over x, and you're going to see that over here. So if I graph it, plug in -3, and I'm going to get another color. I think I'm going to go with indigo again. Yeah, there we go. If I plug in -3, it tells me that I'm going to go down a third. So if I go to -3 on the x-axis, so let me make sure I scale this, -1, -2, -3, +1, +2, +3, -1, -2, -3, +1, +2, and +3. So if I start to graph some of these, I picked the wrong color. Is what I meant to pick. So if I plot -3, I go down 1/3. So that's my coordinate pair. So something like right there. That's about a down a third. And then -2, -1/2, I go left 2, down a half. And then -1, -1. And then -1/2, down 2. -1/3, down 3. And then if I take a look, what you'll see is this nice curve. I'm just going to draw in the rest. So you can kind of see that that curve starts to hug that part of the axis. So you kind of see that nice nature. And then over here, if I plug in a third, I get back 3. If I plug in a half, I get back 2. If I plug in 1, I get back 1. If I plug in 2, I get back a half. And if I plug in 3, I get back a third. So on this side, it almost looks like a mirror image over the XY plane. Okay? So that's what that function's going to look like. And so that's probably the toughest one to graph, and we're just going to check with our graphing calculator that that is true. So let me make sure I've got the scaling set nice, so it'll look like mine. So 1 divided by x, graph it. And if you take a look here, if I zoom in, it does have that nice similar shape to me. And that's all that I wanted to talk about. So recap, the ones that are really important for Algebra 2 are square root, cube root, and absolute value functions. Okay? Piecewise and step functions will come later. Some of these are essential to solve problems later on. That's why we're graphing ones that aren't in those lists. And then if you're in Algebra 1, right, and you want to look at this video, which I may use, I'm actually trying to stick to this curriculum. You want to graph functions expressed symbolically, and you want to graph linear and quadratic functions, okay? So I think there might be more to that standard, so I'll go into that. You want to graph square root, cube root, and piecewise define, and absolute. Yeah, so that's also part of your standard. So let's take a look at this one and see what it says. For B, solve polynomial functions identifying zeros when suitable factorizations are available. Graph exponential and logarithmic functions showing intercepts and in behavior. So we talked about exponential functions. Logarithms are much later, okay? So exponential functions are also important for Algebra 1. So that was 2 to the x. So I would review that one, okay? So that's all I wanted to talk about, and it is time for me to go home. You guys take it easy.